Very good morning to all. Today we are going to look into what is digital image processing and the first introduction to digital image processing. I am Dr. Kavita from MIT campus. What is digital image processing? Let us see two principal areas where this digital image processing is used. Mainly, it is used in improvement of pictorial information for human interpretation and also for processing of image data for storage, transmission and representation for autonomous machine perception. Now, when I use words like a beautiful flower, a cute baby and delicious foods, these words may not be very pleasing as a visual presentation. Now, when I show you a picture of a flower, it is more pleasing than to hear the word beautiful flower. Next, a baby. Of course, delicious food like ice cream. Now, what is a digital image? A digital image, it can be defined as a two-dimensional function f of x comma y, where x and y are spatial coordinates and f is the intensity or gray level at that point. This x and y and the amplitudes of f are all finite discrete quantities, and you can see that an image is made up of finite number of elements which are nothing but the pixels, or we call it as the picture elements. Now, pixels. Now, most digital images are a grid of pixels, a checkerboard of colored squares, as you can see in the picture. As we zoom, these are the representations. These pixel is described by a number, and that is which we call it as pixel, or the picture elements, or otherwise even called as pels. Now, coming to image and its most important term, resolution. Now, the resolution of an image tells us how small and densely packed the pixels are. Now, normally we talk about resolution in terms of DPI or PPI. Now, it tells you how many pixels you have per inch. The higher the resolution, the sharper the images look to a pointer. And monitors have only 72 screen pixels per inch, that is PPI. So, any resolution above 72 won't look any sharper. Now, most web graphics have a resolution of 72 pixels per inch. Now, these are some examples of the pixels per inch. Now, this is an example of 18 ppi, 36 ppi and 72 ppi. So, we can see the difference between the three in these. Now, digital image processing and related areas. Now, we can see that we can put image processing into various levels and work upon them. Now, the first and foremost, we call it as low-level processes, where we mostly concentrate on improvement of the images, mainly for noise reduction and then for contrast enhancement. Next, mid-level processes normally involves what is called as a segmentation, where we try to partition an image or object and get the object of or the region of interest for further analysis. So, in this low-level process, which is otherwise enhancement, and in this segmentation, the inputs are images and the outputs are images or part of images. Now, there could also be mid-level processing involving classification or otherwise recognition of objects. Now, here I would like to also emphasize on what is computer vision. Computer vision, its ultimate goal is emulate human vision or high-level processes when learning, inferences, making actions, taking a sense to a set of recognized objects, perform the cognitive functions normally associated with visions, and there are no clear-cut boundaries. The origin of digital image processing, it was in early 1960s for the space program, and later after 1960s and 70s came the medical imaging, CAT, computerized axial tomography, and remote earth resources observations and astronomy. Now, applications of digital image processing. There are wide applications for digital image processing. Most commonly used application is the medical imaging, where we have the CT, ultrasound, MRI, PET, angiography based 3D reconstruction. Besides, we have remote sensing, where remote earth resource analysis is done, weather prediction, environmental assessment. For defense, automatic target recognition, image tracker, law enforcement in the form of fingerprint recognition, industries for OCR, positioning, alignment, inspection, physics, astronomy, archaeology. Now, image categorization according to the source. Image source can come from electromagnetic, acoustic, ultrasound, electron, computer generated images. So we call them as synthetic images. Now in the electromagnetic spectrum that we know, we have gamma rays, X-rays, ultraviolet, visual rays, which are normally visible to human beings, infrared, microwave, radio waves, and so on. So this is how our electromagnetic spectrum is. So images could be obtained in various bands of this spectrum. So this is an example of a gamma ray imaging. Now we can see a bone scan, a PET image, a Guinness group, gamma radiation, X-ray imaging, medical field for chest X-rays, aortic angiogram for circuit boards, and so on. Imaging in the visible and infrared bands. So this is one typical example for infrared band based imaging. In other examples, we can see medicinal and industrial uses. In the radio band use for spine, bone analysis. Imaging in the microwave band, it's an example of a radar image of the mountains in southeast Tibet. Other modalities, we can see ultrasound based for fetal analysis. We can visualize. Other synthetic imaging modalities, example of synthetic based imaging. Now here is an example of a Landsat images from tsunami in Indonesia in the year 2004. Left you can see its natural color, and this is called as the pseudo color that is normally done to the original images in order to delineate or separate the region of interest from the background. So normally this type of pseudo coloring is done to make better interpretation from the original images.